I sent that to Jim Dower to do literally a month ago.
Brian Thomas here.
Yeah, they have to change their
We're going to go ahead
and I did. I sent him a link to the website and said, Jim, here's.
Okay, we're going to go ahead and get started this morning. Hello, my name is Brian Thomas. A couple quick housekeeping items. By default, we'll have all attendees muted during the presentation and demo. We will be addressing questions at the end of the session, as we do have a fair amount of content to go through in about half an hour. At the same time, feel free to submit questions online as well at any point, and we will address. Again, my name is Brian Thomas. On behalf of CED, Royal Wholesale, and CES, I want to thank you for attending this third session of our monthly application webinar series. The application we're discussing this morning is a zero downtime DCS replacement in a 24/7 critical district energy facility. This application will be delivered by Thermo Systems, one of our preferred integration partners throughout California as well as the nation. At this point, the Thermo Systems team will introduce themselves and we'll get started.
Thanks a lot, Brian. My name is Eric Silk. I am one of the people on the Thermo Systems team. We appreciate the opportunity to give this webinar. My background is in utilities. Chiller plants, steam plants, combined heat and power, district energy, and distributed generation. I'm located on the East Coast at our headquarters in New Jersey. Also on the line, I believe he's on the line, is Corey Notaro, and he is my counterpart on the West Coast. Most of the audience is West Coast California, and Corey is our local guy that can give you local support. With that, I'm going to jump right into it. So today we're going to be talking about a success story case study for a life cycle controls replacement project in a critical district energy facility. And yeah, if we could hold questions to the end, but if I say something that doesn't resonate or if I drop an acronym without defining it, let me know, just so I can make sure we're all on the same page. Okay. We'll go through a quick project intro, talk about the challenges, talk about how we overcame the challenges, conclusions, and Q&A. So first I'd like to give you a client overview. The client was Pepco Energy Services. They are a subsidiary of Pepco Holdings Incorporated, and they're the unregulated arm of Pepco, the utility. So Pepco Energy Services has many capabilities, one of which is they can design, construct, build, operate, maintain central plants, district energy facilities, and in this case, they own the central plant in Atlantic City, New Jersey. Let's see if we can get the video going. There we go. So we're going to talk about the plant in Atlantic City, New Jersey. That's a picture. Well, you don't see the picture yet, but in the plant they have 14 chillers, 3 steam boilers. There's a CHP, which is they've got a solar turbine coupled with a heat recovery steam generator, and they pump chilled water and steam to 13 locations in Midtown Atlantic City. Here's a picture of the front. Just to give you an aerial view of the lay of the land here. You can see my cursor. Let me see if I can annotate. So right here is the district energy facility, and their customers from this district energy facility are in this location. So there's 13 locations which they're selling mostly to casinos, which makes it critical. They have contractual agreements with their customers that they always have to provide chilled water of a certain temperature, steam of a certain quality, and you know, the issue comes if they stop serving the casinos with chilled water in the middle of August, everyone's going to go to a different casino. So it is a critical facility that runs 24/7. They also have remote locations, Atlantic City Convention Center right here. It's a central plant that serves the convention hall. They own a solar field on top, and they run the central plant in the Golden Nugget over here. Let's see if I can get rid of this. There we go. So they do have 13 energy transfer stations from the Midtown Thermal Control Center, and they have 25 revenue metering points, totaling all their chilled water and steam meters that they do billings for their customers. And the projects consisted of replacing their legacy Yokogawa DCS system, which was controlling the Midtown Thermal Control Center plant, which is their district energy facility, and replacing their Viking billing and reporting system, which was also a legacy system. And the Yokogawa DCS was responsible for running the plant, the chilled water and the steam plant, as well as some of the ETS, energy transfer station metering points. And the Viking billing reporting is, you know, self-explanatory, but it also helps manage invoice creation for PEPCO Energy Services. So these two components are pretty critical to their core business. The data that gets sent out of the Viking system, you know, is used for revenue. And some of the tools that we implemented to achieve this replacement was a whole host of Rockwell automation products, but we also partnered with a company called Nexent, and we leveraged their expertise in utility invoicing and accounting systems. We'll talk about that a little bit more later. So some of the big challenges that PEPCO Energy Services had was that they essentially had a completely proprietary system. And, you know, they were left, the Yokogawa system was essentially, they had one contact from the manufacturer who understood the system and who was servicing them. And while he was a really good guy, good engineer, he was always, you know, on the go. He was across the country doing other things, and that was a concern for them. You know, in the event that they needed to make a modification or a repair or a spare part, they were really struggling to find some local support. And same thing with the reporting system, the Viking reporting system. That was 100% proprietary, and it was a custom build for them, and there was one person who understood it. The documentation was not good, and that was a big risk for them. Also, the DCS system was really controlling many, many different systems within the Midtown Thermal Control Center. It was controlling the entire chiller plant. It was controlling the feed water system for the steam plant, and it was also controlling the combustion control systems for all three of their boilers. And that was a big risk because the combustion control systems for their boilers did not have a local HMI, meaning if the DCS were to ever go down, they had no local operation of their boilers. So again, they had many independent systems on one DCS. All their eggs were in one basket, and they didn't really understand how to service and maintain this basket, and the basket was getting pretty old. So it was time to upgrade. And then the billing system, while it was proprietary, but it was also very highly manual, and that was a risk item for them. I mean, they had one person dedicated for running this manual operation to generate a bill at the end of the month, and it took him 2 weeks if everything went smoothly, and we'll get to that later. So we were able to really streamline this entire process for them. We were able to mitigate their risk by implementing some different strategies. I talked about some of the remote plants they had as well, Atlantic City Convention Center, Golden Nugget. They also have a plant in Wilmington, Delaware, that their district energy facility in Atlantic City was responsible for operating and generating invoices for. And they had inconsistent ways of communicating to those plants. One had a dial-up modem where they would extract some revenue data. One had a T1 line. One was completely manual. And we wanted to get them to a more streamlined process that was more reliable, consistent, and standard. We'll talk about that. So we got involved because we were able to work with them in a main automation contractor capacity. We have capabilities to take the project from its conception all the way through commissioning and support the system throughout its life cycle. And this was one of the big keys to the success. We were able to really help the customer develop a strong user requirements, beginning the project with their end goals in mind from a controls perspective, and able to help them through technology choices, software platform choices, by really asking the right questions in the beginning to, asking them what's important to them, and not just the managers, but the operators and maintenance staff. And this is one of the markets that we're very strong in. Yeah, so the way we approached the project is we met with the customer and we asked a lot of questions, and we helped them draft a user requirements document, asking them, was dashboarding important to them? What kind of reports do they want to see at the end of the day? What kind of functionality do you need out of the system that you know about? And let's talk about your growth, and let's look at some needs you may have that aren't identified yet. And we really spent a lot of time at this phase early on, having meetings with them, driving meetings, and we built out a pretty robust user requirements, which paved the way moving forward. We decided on a phased approach where we put together a complete detailed design prior to implementing, and part of that detailed design, a very robust transition plan. And this transition plan was the document that really helped us mitigate risk through the implementation. We came up with a phased implementation approach where we could pluck systems out of the DCS strategically, get them up and running, and then we isolated the DCS control function simply only to the chiller plant. And the chiller plant could be run in hand completely. So when we were ready to pull the plug on the DCS and do our rip and replace, which is this approach we took, the only thing that DCS system was responsible for was the chiller plant. All of the boilers were up and running individually. The CHP plant was up and running. We're getting good data from the energy transfer stations through a new PLC, and that was really the key, the transition plan and the user requirements, if I had to emphasize something. A little bit more about transition plan. The DCS was controlling the DA tank and the boiler feed water for the boiler plants and the CHP. So we got those functions into a dedicated programmable automatic controller. We put local controls on each of the boiler combustion control systems. So as we were going through this transition, if there was an issue with the DCS, the operator could still walk up to the boiler and run their boiler, if the plant master went down. We migrated all of the energy transfer station revenue grade metering feedback out of the DCS into a separate data concentrator. So now they were getting their good data coming back to a separate new ControlLogix PAC. And then finally, we dealt with the chiller plant at the end. The other thing that was interesting is we installed a new PAC at each remote building. Atlantic City Convention Center, Golden Nugget, Taj Mahal, Wilmington, Delaware. And we created a firewalled connection to each plant with a standard metering strategy so that this data concentrator was looking at each of those remote PLCs on dedicated networks and bringing in the important revenue data. It was very clean. We also leveraged, moving away from the DCS had its complete process control and visualization package. But when this combined heat and power plant project was going in, we were installing a Rockwell Automation SCADA and a new historian. So we leveraged that install, and we were able to bring systems to the new SCADA system while they were also on the DCS. So migrating from the DCS to the SCADA, they basically had two screens in parallel. And that also helped us validate data as it was coming in. So this is a flow diagram on what the systems looked like before. The energy transfer stations were all on a big fiber network coming into a PLC5, which was in the same enclosure as the Yokogawa DCS. And it was feeding information into the DCS and then up to Viking billing system. DCS also had control of boiler 1, 2, and 3 combustion control systems, DA tank, chilled water balance plant, and it also did some remote metering of a few ETSs. And this is what we went to, a more distributed approach, if you will, where the ETS is now pointed to a new ControlLogix PAC, and that did all the data aggregation, and that was funneling all the information up to the new SCADA. So we isolated critical metering points into a dedicated PLC, basically upgraded that PLC5 to the ControlLogix, and moved these ETSs over to the PLC, and installed new controls for each boiler, a dedicated one for the DA tank boiler feed water system, and a dedicated ControlLogix for the chilled water balance of plant system. This is just a picture of what the DCS panel looked like right when we pulled the plug, or I shouldn't say right when we pulled the plug. So we pulled the power. Everybody was in the right place. We were following the transition plan. This is when the DCS was only controlling the chiller plant. So now we got the chiller plant running in manual. We were fully staffed. All the operators were on site. We had a bunch of controls guys on site. Pulled the plug, and then it was time. We were on the clock. So we tagged and determined all the cables, pulled them out, brought in our new panel, dropped the cables back in to the top. We had this cable wire tray, because these were all plenum-rated cables, very heavy, a lot of weight on the insulation. And then this is the final product, ControlLogix dedicated balance of plant PLC for the chiller plant only, whereas before there were many, many other systems coming in here. This is the flow chart that the client was following to run their bill at the end of every month. And each one of these items, I'm not sure how clear it is on your screen, but each one of these items here is a separate Excel sheet. And then each one of these boxes represents some sort of manual activity that their billing manager would have to take. And the problem with all this, they would go through all of this work, all this information would make its way into this master Excel sheet, and then they generate an invoice, But the issue is once it got into here, they could see if something was really wrong. But it wouldn't be till 2 weeks after the billing cycle. So then what do? Then you have to go and have a conversation with the customer. We found some data that doesn't really match. They might interpolate or extrapolate and fill it in manually or delete data, and they could potentially be missing out on revenue. And this is what the new data flow looked like, fully automated. No more Excel spreadsheets. All of the revenue data was being brought into either the data concentrator PLC or directly moved with Transaction Manager. So Transaction Manager is a piece of software, and all it does is it takes data from a PLC and puts it in a SQL database. And this was really cool because this is how we delineated the scope between the process control system that Thermo was really responsible for and the Nexent billing software system. We used Transaction Manager to dump all the chilled water revenue data, the steam revenue data into a SQL database. And then the Nexent billing software would take the data from that SQL database and use that to automatically generate invoices. And this Nexent system was really cool, and it was something that Thermo Systems was involved with. You know, when we generated the user requirements, we interviewed many software companies to find the right solution, and Nexent really had all the tools we were looking for. It truly is a utility billing, invoicing, and accounting system. You know, they can create an interface so Pepco's customers could log on the website, pay a bill, see their billing history, and that was really key to bring them in. Another thing we added at the end was dashboarding. So once all the the process controls at the plant floor were replaced, once we calibrated all the instruments, once we got the Nexent system going, and we had good visualization, we verified that there was good data. We implemented dashboarding for them. There's a 60-inch flat screen next to the manager's office, and it's on a kiosk. And they can see at a glance, you know, walking around, walk out of their office, look at this, or they can pull it up with their workstation or even pull it up on their iPad from home. And they can see at a glance what their plant's doing. One of the really cool things about this, if I could just annotate, if you see here, at each ETS, there's a gray shaded area, and then there's this blue bar in between. The gray shaded area represents what they're projecting to bill that customer before the billing cycle. And then this updates in real time with this blue bar. They can see how much they've billed on a tonnage basis. So it's the actual versus their budget. So they can see how they're doing. They can see if they're beating their budget, or they can see if they're not really billing anything, and that's a problem. So they can fix the problem immediately, and as opposed to what they were doing before, and they get all this information 2 weeks after their billing cycle. So this is a real-time actual versus budget tool that was very powerful for them. And then all the other good stuff, the good KPIs. You can see their turbines not running right now. They're importing, and you can see their plant steam production with little dials to see if they're in a good area or if there's a problem. So let's go to the next screen. And then this is a dashboard that kiosks, and they can see their remote plants. So also at a glance, they could see, you know, what the Wilmington plant is doing, or what their Atlantic City Convention Center plant is doing. And this is a really powerful tool for them. So instead of not knowing or having to call the plant manager at those remote plants, they can see in real time. So here's a list of the software and hardware we use to implement this solution. And here's some conclusions. Let's get them all out here. Yeah, the main point is really investing a lot of time in thinking about what you're going to need today, but also what you think you're going to need in the future. So you select a solution that's scalable, that you can grow into. You may not think you need dashboarding or reporting or having KPIs right now, but select something that you can grow into. Definitely put a lot of time into thinking about transition plan, identifying all the risk areas, and coming up with the risk mitigation plans and disaster recovery plans as you're replacing the critical control system. And it was key to really meet with all the plant operators, see what's important to them. You know, what do they want to see out of the system? What are their concerns? And teaming. And really the benefit for the client, you know, we asked the client what was the benefit for them. And they said the big benefit that they got out of this project was they were able to view all of their operating sites in real time, completely changed the way they managed their systems, completely changed their day-to-day activities. Instead of hopping in the car and driving over to Atlantic City Convention Center, they could see all the data real time. Instead of waiting for the end of the month to manually create an invoice, they could see if they were meeting their projected billings in real time on a dashboard, on a report. And that it completely changed the way that they operated their plant. It freed them up to do things like, you know, maintain better, to do optimization projects, as opposed to, you know, worrying about, was this DCS going to fail? Was the billing system going to fail? What do we do about it? And yeah, the real-time profitability forecasting. So that's the presentation, and just a couple notes on Thermo. So we really add a lot of value in the energy and consumer sectors, a lot of expertise in utilities, facilities, CHP, chilled water plants, boiler plants, power gen. We also do work in life sciences, food and bev, and consumer packaged goods. And, you know, we really have a broad range of capabilities, anything from doing a calibration on an instrument to, you know, helping you build a new plant, working in a main automation contractor capacity, furnishing and installing all the instruments, control panels, SCADA, managing electrical and mechanical subcontractors, managing MEP engineers under us, really being one point of contact for your whole project. Also have a dedicated service department that offers 24/7, 365-day a year on-site and remote support. And we're distributed across the United States. I'm located here in New Jersey. Corey is over here in California. And that's it. I really appreciate your guys' time, and happy to field any questions. I think we're at 25 minutes or so here, so I'll open it up.
Yeah, it's Brian Thomas here. Eric, thanks so much for taking the time to do the presentation. Yeah, so we do want to open up for questions at this point. So if you have any questions, please weigh in.
Remember to unmute first.
So if we don't have any takers, I'm going to actually ask one question in the short term.
Sure.
Obviously, there was, from a reporting standpoint, a criticality of that data with the revenue data. Can you speak to what kind of, just briefly, the strategy there in regards to what they elected to do in regards to, from a systems standpoint or architectures, as to redundancy or being able to make sure that they get the data that they need and that they don't lose data?
Yeah, I can speak to that. There were a couple different pieces there, because the data, the revenue data, it really dominated a lot of our conversations. Everything we were doing and the whole transition plan and the user requirements and the implementation approach, we always said, you know, is there a risk of losing data here? What if when we install the new system, the data is completely different than what we've been using. You know, there's a risk, are we overbilling or underbilling our customers, and how do we explain that? So first, we took a couple steps and, first of all, calibrated all the critical instruments, make sure they were in good working order, validated the data there, made sure that they were using the right steam lookup tables and temperature and pressure compensation. Then installed the new Nexent system in parallel with the Viking billing system. And we did a cross and compare, you know, just to see, does this make sense? Is something way off? And, you know, it actually looked pretty good. But then also moving forward, and I should also mention, while we were going through this construction process, we were going around to the local revenue meters and taking manual data readings, just in case something went awry. So we were doing manual readings for about a month, cross-checking everything. And then for the final product, when it was time to demo the Viking billing system, we have automated backups happening weekly of all the data that is getting stored at Pepco's facility in Atlantic City. And then we also have backups that we're bringing to our office as well. So 2 locations. Not sure if that answered your question.
Okay. Appreciate that. Any other questions? Okay, well, I think we are just about done then. So thank you to Thermo Systems team for presenting and for all that attended. If you would like to have additional discussions on this or related topics, please feel free to reach out to the Thermo Systems team or reach out to your CED, Royal Wholesale, or CES sales reps, and we can discuss further. If there are no additional questions, we will now close out this session.
Thank you.